Okay, this is your homework video for lessons 62, 63, 64, and there weren't any for 65. Actually, there weren't many problems at all listed on the help board by 3:16 on Wednesday afternoon. So I'm going to do the ones that are up there, but I can't do any tonight. I'll be out of the house tonight. So let's get started. The first one was number 11, and I did that one on the help board. We won't have any questions of statistics on the test. Those you can just do on your calculator. The thing that you have to keep in mind is 60% of the data lies between the first deviation. 95% of data lies between the second standard deviation. So I sent you a little video on that, a couple videos, and I also put some stuff on the help board. So read that. Okay, let's start with number 25. Someone is having trouble with these kind of problems. So if this does not clear it up, please see me at Compass or send me an email and let me know that you're the person that does not get these. Because these we've been doing for quite some time, and there's just something that you're not getting that maybe if I explain it to you, you'll get better. So let's give this one a whirl. I always change these into degrees. Just makes it easier. If you can think in radians, that's even better. So I'm going to change these into degrees. All you do to change them into degrees is you take 19 times 180 and divide it by 6, and you get 570. Fortunately, we have exactly the same for cosine, and the sine is 19 times 180 divided by 3 gives you 1140. Now these are not in the 360 degree range, so you have to subtract 360 from these as many times as it takes to get it within the 360 range. So if I subtract 360 from 570, I get 210, and this would be, let me put my little degrees on here, this would be the cosine of 210, and I would have to subtract 360 multiple times from this one until I'm going to get the sine of 60 degrees. Now you just have to figure these out the old-fashioned way. So 210, and you can start becoming more familiar with these, you don't have to do all this work. 210, this would be 180 plus a little bit more, like that. I'll just extend that down and make myself a triangle. So 210, that would make this a 30, because 180 plus 30 is 210. This is 1, 2, square root of 3. This is negative, and this is negative because the point is in the third quadrant. The angle's in the third quadrant, put it that way. So, and then so we can figure out the sine of 210 is just the sine of 30, which 30 would be the sine would be opposite over hypotenuse, so it's negative 1/2, because the one opposite is a negative 1. The cosine of 210 will be adjacent, so it's negative square root of 3 over the hypotenuse. And then we just do the sine of 60, which would be up here. So we would get 1 square root of 3, 2. They're all positive, so the sine of 60, this is 60, is the square root of 3 over 2. And we just multiply that out. The 2's cross out. Negative times negative would be positive square root of 3 over 2 minus square root of 3 over 2. So that's our first problem. So we're done with lesson 62, since I'm not doing 11. 63, let's hit number 9. Lesson 63, number 9. I'm doing the speed version, so I'm going through homework, it looks like. Okay, 9, you have an equation for a circle. This is not in standard form. This is probably called general form, but that's not standard form. The question says, this is an equation of a circle. Complete the square to change the equation to standard form. Find the radius and the coordinates of the center of the circle and then graph the circle. Okay. Standard form would be of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. So we're going to do two perfect square trinomials so that we can factor them into the quantity squared, and we're going to put all our other numbers on the other side, and that will be the radius. So group the x's together, x squared plus 8x plus something to make a perfect square. Group the y's together, y squared minus 6y plus something to make a perfect square. So this is going to be a perfect square trinomial, and pop the 11 over there. And we have to add the two numbers that we add to complete our perfect square. So you take 8 divided by 2 is 4. Remember that, 8 divided by 2 and square it. It's 4, so it's 16. 6 divided by 2 is 3. Square is 9. So we have to add a 16 and a 9 over here. Perfect square trinomials factor into x plus 4 quantity squared, because it would be x plus 4, so we write x plus 4 quantity squared. Y minus 3 quantity squared, and that all equals 36. So we can find the center of our circle would be HK, so that would be negative 4, 3, and the radius is equal to 6. We would actually write this side as 6 squared if we want it in standard form. Then you simply graph that. You put your center down. Just remember, your center is always the opposite of this. So your center is negative 4, 3, and then we're going to go 6, 1, 2, 3, 4, 5, 6 would be about here, and then we would just, you could take a compass or you could just guesstimate it until you get a circle whose center is there and whose radius is 6. So it looks something like that. Okay, the next one we're doing is less than 63. 13 is another statistics problem. So we're not going to have those on tests because we use our calculators to do that. So let's move on, and I'd encourage you to read what's on the help board. Lesson 63, 27. This is 63, 27. This is like the first problem that we did. So let me look at that one. Okay, same idea. If someone's stuck on this, they need to see me because we've been doing these for a long time. 3 pi over 2 plus cosine squared of 3 pi over 2. Isn't that handy? Okay, now if you put that in your calculator, divide by 2, you would get sine squared of 270 plus cosine squared of 270. You could either plot this and figure out the sine and cosine, or you can think of your sine and cosine curve. This is what I like to do. I just think of this in my mind. I don't draw this every time. Here's our sine curve and our cosine curve. Let's see. This, it would be 0, 90, 180. This would be 270 and 360. This peaks at 1 and it valleys at negative 1. And the cosine curve peaks at 1 and then it hits 0 and it valleys at 1, hits negative 1 at 180. So it looks like this. Something like that. I'm really bad at drawing my curves after I have the numbers on it. So we'll use these graphs even though this cosine one's really bad. So let's just look at the graph, just picture that in your head. 270, the sine of 270, so we go to 270, the sine is the white line, it's minus 1. So we just put minus 1, let's do that in white, minus 1 squared. So if you look at the sine of 270 is minus 1. The cosine of 270, look at this, it hits 0 right there. So it would be 0 squared. So the answer to this problem is just 1. Okay, next one is, we're on lesson 64, number 9. Lesson 64, number 9. Can't wait to see what that is. Okay, this is one of our cis problems. It's 6 cis of 300 degrees times 2 cis of 30 degrees. Now we're entering the complex number system. So this is a complex number. In order to multiply them, multiplying is easy. We talked about you just take 6 times 2, so you would get 12, and then you would get cis of 300 plus 30. So that would be cis of 330. Alright, that is still in polar form, however. The cis is a polar form of a complex number. Now we can separate it into rectangular form. And all you do for that is you take 12. The C stands for cosine of 330. And the I stands for imaginary number. The S stands for sine of 330. And now it is in rectangular form, and we can actually find the cosine of 330, the sine of 330, and we'll be done with this problem. So let's do our little graphs. Y, X, 330 would go the whole way around here. It covers all but 30 degrees, right? 30 plus 30 gives 360. So this is our 30 degrees. So we're going to get, I'm going to mess this one up, 64, 9. I'm just double checking myself. Alright, so cosine, yeah, this is pretty easy. Okay, cosine, this would be 1. It's actually negative 1. 2, square root of 3. So we get cosine of 30 is adjacent. It's all going to be positive. Square root of 3 over hypotenuse plus, and then we're going to have a sine of that, which is going to be negative 1. I guess I didn't need to keep that. Negative 1 over 2 pi. And so we're going to distribute the 12, and we get 6 square root of 3 minus 6 pi. And I do believe that is the final answer for this in rectangular form. Okay, last problem we're going to do is number 27. I did these all in one video because there weren't very many problems, unfortunately. Okay, lesson 63, number 27. And what kind of problem do we have here? 27, oh great. Y equals x squared minus 2. Y equals 2 minus x squared. They say to sketch the graph of those, and then we're going to shade in the inequalities. Y is greater than or equal to x squared minus 2, and y is less than or equal to the graph of 2 minus x squared. I'm going to pull a little graph up for myself. Hold on one second. It takes me a second to do. I think I store my graph somewhere on my computer. There we go. Alright, here's a little graph. That'll just help it to be a little bit neater. Okay, this is a parabola. So we have the y-intercept. If you think about it, y equals x squared is a parabola with the center at the vertex at 0, 0. So when it's negative 2, our vertex is going to move down 2. So we have a vertex right here, negative 2. The constant at the end of a quadratic equation is always the y-intercept anyway. And then I'm just going to pick a point real quick. I'm going to put a 1 in for the x, and I get 1 squared minus 2 is negative 1. So if I put 1 in, I get negative 1 out, and since we don't even have to pick another point because we know that this is also the line of symmetry. So our first parabola is going to look something like this, and that's our first parabola. And it's all the values that are greater than the parabola. So it's going to be, if it was under here, it would be less than the parabola. So we're going to have all the ones greater than the parabola. So it's all going to be in here. Now we're going to graph the second parabola. I'm going to rearrange this just to make it easier to graph. This time the y-intercept right here is 2. So I'm going to put a point on 2. 1, 2. Put a point there. The parabola is going to open downward by noting that negative sign, downward. And if we pick a point, if I pick 1 again, 1 squared would be 1, but it's a negative 1. So negative 1 plus 2 is 1. So we're going to get a point at 1, 1, and then on the opposite side. So we have enough information to draw a parabola. And this time, this is less than, so it's going to be underneath the parabola. So it's going to be down here. We're going to color in. And where they overlap is the solution to this problem. So they overlap right in the middle. And so this is our solution, right in the middle. Okay, that was all that was on the help board. I will, if you put more problems on, I'll get to it, but I can't get into it till at least tomorrow. So that's it. Make sure you get your quiz and test for me tomorrow.